Math 1332, Chapter 11, Statistics, Section 1, Gathering and Organizing Data, Video 6, Frequency Distributions for Numerical Data, Example. I made a decision in the last video to end it before we got to the example because the video was already getting fairly long. But just to quickly summarize what we did, and I do mean quickly, we're going to build a frequency distribution, a grouped frequency distribution, by creating classes of values like 18 through 21, 22 through 25, et cetera, using some information. And the information that we're going to use is we're going to calculate the class width by subtracting the highest minus the lowest, dividing by the number of classes and always rounding up. We're going to start our first class with the least value in the data set. We're going to take that class width and add it to the lower limits to create the lower limits for following classes. Then we're going to figure out the upper limits by backing up the lower limits by 1. And then the last upper limit will just follow a pattern. But let's do an example. The percent of people killed in car accidents who were not wearing seatbelts in a given year shown for 50 states. I don't know how accurate these numbers are, borrowed from example in the online homework that we're using. Construct a frequency distribution using 5 classes. All right, so let's think about what our end goal is. Our end goal is to have something like this. We're going to have a table that's going to have 5 rows because we want 5 classes. The first column will represent the number of, what was it, percent of people killed in car accidents. So we'll just say percent of people. Where'd my table go? There it is. So we'll just say that this will be percent of people. And then we'll have the frequency. So we'll need something to something, something to something. These are all numbers in here. Some number to some number, some number to some number, and then some number to some number. And then we'll count how many values fall in each of those categories. All right, but in order to do that, we have to figure out where this one starts and how much to add to get from one lower limit to the next. In other words, the class limit. So let's start by making a note that we are building 5 classes. Now we have to find the lowest and highest values. And unfortunately, these are not in any particular order. If there were an Excel spreadsheet, I would just sort them or ask it what the min and max are. But let's just pick one and then we'll change it until we know it's not that one. So 33.1, come back. 33.1 seems to be the lowest. Just looking down, 33.1. Looks like it shows up a couple of more times, but there's not one lower. So it looks like 33.1 is the lowest. Now we have to find the highest. In scanning through these, I saw 70.5. I don't know if it's the highest. Nope. Look right below it. 71. But let's go through all of them to make sure. Any that start with 7. I'm just looking in the first digit on each number. There's a 73.3. Oops, come back here, you. There's a 73.3. That's higher. 74.4. That's higher. It looks like the lowest is 33.1 and the highest is 74.4. I'm going to cheat and look on my spreadsheet, and yes, those are the lowest and highest values. All right, so now that we have our lowest and highest values, we can do our first step, which is to calculate the class width. The class width, or just width for short, is the highest value, 74.4, minus the lowest value, 33.1, divided by the number of classes. That's just a straightforward calculator problem. There's no need to really dilly-dally with it. When you do the math, you get 8.26. At least that's what I got. But here's where this part comes into play. Always round up to the desired number of decimal places. Our data has 1 decimal place, so our class limits should also have 1 decimal place. This is going to round up. Now, normally what you would do is you would look at this digit and make a decision about whether or not to round up. But always round up when you're calculating class width. In this case, it's the correct way to round it, but I can't stress that enough. you always round up. So this would round up to 8.3 when calculating class width, regardless of what that next digit is. Our class width will be 8.3. Our next move is to start the first class with the least value, and then add the class width repeatedly to get lower limits for all desired classes. So at this point, we're going to open up every single class using a class width of 8.3. Let's go ahead and start drawing our table. Our first class begins at the lowest value, which was 33.1. We'll close off that class in a minute, but we need to open up all the classes by adding the class width. So we're going to add 8.3, then we're going to do it again, and we're going to do it until we have 5 classes. So we'll have to add 4 times. All right, 33.1 plus 8.3 is 41.4. 41.4 plus 8.3 is 49.7. 49.7 plus 8.3 is 58.0. Feel free to use a calculator. 58.0 plus 8.3 is 66.3. That's the role of the class width to go from one lower limit to the next. Step 3 we just did. Step 4, the upper limits for the classes should be the last value before the next lower limit. All right, this is where we have to use a little bit of caution and discretion. In order to close one class, we have to see where the next one opens and then preserve the correct number of decimal places. If we want to figure out where the first class closes, we need to see where the next one opens. The next class opens at 41.4, and we are measuring to 1 decimal place accuracy. So we need to dial this odometer back 1 digit in the last decimal place. So dialing it back from 41.4 means that this one ends at 41.3. And we can do the same thing with the next lower limit to back it up to figure out the, go back there, to figure out the next, the previous upper limit. If the third class begins at 49.7, then we have to dial that back 1 digit in the last decimal place, and that's where the previous class will end, 49.6. Then, to figure out where the third class ends, we need to see where the fourth class begins and take it backwards 1 in the last decimal place. If we dial 48.0 backwards 1, we get 58.0 backwards 1, we get 57.9. Then we do it again here. The fifth class begins at 66.3, which means the preceding class, the fourth class, had to end at 66.2. We want to make sure there's no gaps between consecutive classes so that every number has a place to live. Now, the problem with the last one is there is no next class to back it up from. But the upper limits are going up by the same amount as the lower limits. They're going up by the class width. In fact, this is another way that you can build the upper limits. Once you know the first upper limit, you can just repeatedly add 8.3 to build the rest of the upper limits. This makes the last upper limit 62.2 plus 8.3, which is 74.5. So just remember, the first class begins with the lowest value. The class width that you calculated in step 1 tells you how to progress from, give me 1 second here, how to progress from one lower limit to the next, to the next, to the next, to the next, at 8.3. The upper limits do the same thing. They go up by 8.3 also. But in order to figure out where they begin, the first class ends right before the second class begins. And then again, you can just add 8.3 to create your upper limits, or just back up a lower limit to figure out the preceding upper limit. But either way that you do it, you should get the same classes. All right, let's clean this up. All right. So I went ahead and set up a table that we're going to complete and labeled each column, the left of which is the percent of people killed in car accidents who were not wearing seatbelts. And below there are the classes that we built using a lower limit of 33.1 because you remember for the first class, and remember that 33.1 was the least value in our data set, which actually occurred multiple times. And our class width was 8.3, which was obtained by subtracting the lowest and the highest and dividing by 5 and rounding that up to 8.3. That lower limit was used to add to get, that class width was used to add to get from one lower limit to the next. And our upper limits were 1 decimal place less than the previous or the following lower limit. All right, so our classes are built. The hard part is over. Now all we have to do is count. All we have to do is count how many values fall in each frequency. Now this can be a little bit cumbersome because there's a lot of data to filter, but you know, it's just counting and being observant. All right, so now we are looking for the number of data points that are between 33.1 and 41.3 inclusive. I'm going to go through and try to circle them. That's not a circle. Circle, please, or draw. There we go. 33.1. All right, so I need everything that is less than or equal to 41.3. So if I see something, all the 30s are good. And if there's a 40, I have to see if it's less than 41.3. Okay, here's a 40 that's less than 41.3. All my 30s are in this. And any 40 has to be less than 41.3. There's a 30. 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 And again, especially in a data set this large, it will be easy to miss values. So the circle and crossout technique is pretty important here. I think I found all the numbers between 33.1 and 41.3. If I missed some, we'll figure it out later. Let's count them. 1, come back here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Actually, I'm going to show you another technique, and this will work. But sometimes it's better to just process every number in the order that you see them by using tally marks. For example, 33.1 falls in the first class, 63.9 falls in the fourth class, 35.2 falls in the second class. Of course, this is easier. 52.5 falls in the third class. Be very careful. 56.9 falls in the second class. 57.9 barely falls, third class. 57.9 barely falls in the third class. 49.3 falls in the second class. 45.5 also falls in the second class, as does 45.3. 69.2 falls in the fifth class. 59.1 falls in the fourth class. 41.1 falls in the third class. I'm going to pause the video. Actually, I'm just going to process them. I want you to watch this. 37.9 falls in the first class. 38.2 is in the first class. 5 tally marks, you put a slash through them. 45.9 falls in the second class. 56.8 falls in the third class. 33.1, which shows up twice, both fall in the first class. 70.5 and 71.0 fall in the last class. 55.7 is in the third class. 60.5 is in the fourth class. 43.3 is in the second class. 50.2 is in the third class. 57.5 is in the third class. 46.6 is in the second class. 57.4 is in the third class. 47.5 is in the second class. 62.3 is in the fourth class. 61.3 is also in the fourth class. 73.3 is in the fifth class. 42.4 is in the second class. 47.6 is also in the second class. 43.3 is in the second class. 36.6 is in the first. 72.3 is in the fifth class. 39.3 is in the first class. 33.9 is in the first class. 62.3 is in the fourth class, 74.4 is in the fifth class, 51.2 is in the third class, 46.0 is in the second class, 72.7 is in the last class, the fifth class, 67.1 is also in the fifth class, 64.0 is in the fourth class, 36.5 is in the first class, 60.4 is in the fourth class, 66.6 is barely in the fifth class, 39.8 is in the first class, 60.0 is in the fourth class. So it looks like our frequencies are 12, 11, 9, 9, and 9. Now this is a problem in the homework that I've been working on, and I'll just type in the frequencies to make sure that I didn't make a mistake. 12, 11, 9, 9, 9. I know you can't see it right now, but that's okay. But I left it open just to make sure that, yep, okay, I can count, hooray. But for some people, the hardest part is what we just did, figuring out what goes where, just because there's so many numbers to focus on. But honestly, I think the hardest part is building the actual classes themselves, because you have to calculate the class width, you have to build the classes correctly, and then count them all. All right, so it's straightforward, but there's a lot of places to get tripped up and lose focus. So stay focused and you should be okay.